Hello guys, and welcome on this video on CMake. This is going to be the start of our journey as we learn about CMake. We are going to try and understand what CMake is and why we need it. Then we're going to look into some of the little details you need to know about to build C++ projects with CMake. We're also going to look at the tools we're going to be using in this tutorial, and the main goal really is to be able to build C++ projects that can run on different platforms. For example, we have a C++ project and we want that to be able to run on Windows, Linux, Mac, and even other platforms like iOS and Android or even embedded devices. But we are going to start small and really focus on desktop platforms in this series of tutorials. I have to say I don't own a Mac, so what I will be showing you will basically be on Windows and Linux. But it shouldn't be that hard to port the ideas we're going to learn about on Windows and Linux and use them on a Mac. Okay, so let's talk about what is CMake and why do we need it. CMake is the build system generator. Some people think of CMake as a build system itself, but CMake is not a build system. It is a build system generator. So the way you use it, you structure your project in what we call a CMake list.txt file, what you see here. And this is going to store information about our project. For example, we can say the header files we have in our project. We can put in the implementation files or .cpp files. We can say which compiler we are trying to use in our C++ project. You can really do all kinds of crazy things. And this information is going to be stored in this file, which is called CMake list.txt. We're going to have a chance to learn about the syntax you're going to use later in the series. Okay, so once you have your project described in this file, you're going to pass that to a CMake engine. Okay, so when CMake tries to process this file, it is going to try and see the operating system and platform where you are trying to build your C++ project. For example, if you are on Windows, it's going to do a set of different things. If you are on Linux, it's going to do another thing. If you are on a Mac, it's going to do another thing. Okay, so now we have passed our input to CMake, and what we get out of CMake is not a build of our project. Because remember, the goal is to build your C++ project. So what you want is a binary that can run on the platform where you are building your C++ project. But we don't get a binary from CMake. What we get is a set of files that we can build easily on the platform. For example, on Windows, by default, CMake is going to generate a Visual Studio project that you can then build using the Microsoft Visual Studio IDE, or even on the command line using the build tools that Microsoft has. If you are on Linux, by default, it's going to generate a Unix Makefiles project. This is the default tool that is used on most Linux systems, and we're going to see more details about how this works later in the series, but I want you to understand that what you get out of CMake is not a build of your C++ program. It is a set of files that you can then build easily on whatever platform where you want to build your C++ project. And to really understand how CMake makes things easy, let's go up and see what you would have to do if you're not using build systems or build system generators like CMake. What you would want to do is to call the compiler yourself. And for example, if you happen to be on a Windows computer, you're going to run a command like this to call the C++ compiler on Windows yourself. If you happen to be using some version of GCC on Windows, this is what you're going to do. Okay, to really see that, here I have a simple main CPP file, and let's bring up a terminal so that I can show you what is inside here. Okay, so I have some things here I am going to clear because I want you to see how these things work. Okay, so here I have a terminal opened to this location where I have my main CPP file. If I do dir, you're going to see that this is a file here, and I can cat and print it out on the console here, no problem. And we're going to see that I have a simple C++ program. It is going to be compiled in C++20 mode because we are using C++ concepts here, and they are supported in C++20. Okay, so now we want to compile this program and run it on Windows. On Windows, we have a couple of options. We can either build this using the compiler from Microsoft, which is CL here, or we can use a version of G++ or GCC that runs on Windows. Let's start and compile this program using the compiler that comes with GCC tool collection. So for example, we can go down here and type this command. This is the command we're going to use to compile this program. And when I compile it, I am going to get a binary that I can then run and do things with it. And before you do this, you should have GCC installed on your computer. So if I do GCC version here, you're going to see the version that I am using. It is GCC 10.20, but what we really want is the C++ compiler, and that happens to be G++. So we can do G++ version here, and we're going to see the version that I am using. If you wonder how I got this version of GCC, there is a guy who was generous enough to provide builds of GCC that we can use on Windows, and I think, can I find that guy here? No, we're going to have to search. So let's go here and say winlibs. And this is a guy who builds G++ versions, or I should say MinGW versions that wrap around GCC versions. And they happen to be using recent versions of GCC. So this is a good way to get a handle on a recent version of GCC on Windows through the MinGW project. You can click on any of these links and you're going to download a version of GCC you can use. We can even go on his GitHub. I think we can get there. Let's go back and see if we can get that. Okay, so here we are at his GitHub link. This is the project. If you go on releases here, okay, you're going to find that they even have a version for GCC 11. We are in March 2021. GCC 11 is scheduled for release in May, I think, but we have pre-releases we can try out here. But I don't recommend using this in production code. You shouldn't really do this. And they have a warning here. You shouldn't use this in a production project. What you would want is to use a release version, and here you have the latest release. It is GCC 10.20. And if you want to download it, you're going to go down here and make your choice here. If you are on a 32-bit system, you're going to want to use i686, this version here. If you are on a 64-bit system, you're going to want to use some version of x86-64 here. I personally like to use these MinGW versions because I don't care for LLVM here. So I would choose something like this, for example. If you click here, you're going to start downloading this and you're going to extract this somewhere on your system. And mine is usually stored in my C drive. Let's go there and actually show you that. Let's go in C. I have a folder for MinGW64. If I open this, I have a bin directory and I have my C++ compiler here that uses GCC. And it is what we see when we run G++ version here. So I really want you to know the tools that I will be using in this series of tutorials. Okay, so this is one compiler. If you want, you can also use the compiler from Microsoft. If you go to the start menu here and hit Visual Studio, you're going to see that I have a couple of Visual Studio compilers. I have 2019, 2017. I have all these versions because I happen to have a few projects I am working on that require me to use these compilers. But for this series, I will be using the latest version I can get my hands on. And this happens to be 16.10, if I remember correctly. Let's actually open this and show you that you can look at the version that I am using. So I need to restart my computer because before I can use this. So we're going to let this be because I don't really want to do that, but you should have a version of Visual Studio installed on your computer to be able to use their compiler. Okay, so let's get back to what we were doing. Now that you know the compilers that I am using, we have a project here and we want to build it using one of the G++ compilers. So let's do that. We're going to bring up a terminal that we're going to use to really build this bad boy here. And let's bring this up so that I can see my command here because I don't keep these things in my mind. So we're going to run this. We're going to run G++ and we're going to say G because we want to compile and link this program. We're going to say the C++ standard that we want to use. We're going to use C++ 20. And we're going to specify the input file, which is going to be our main CPP file here. So we're going to put this in, and we're going to specify the output of our program. So the output is going to be a program named Rooster, because that's what I like to name my programs. So I am going to say Rooster. You can name this however you want, and it is going to build and give you a binary named the name that you pass here. If I hit enter, G++ is going to build my program, and you're going to see that I have a binary file generated here. It is called Rooster, and I can run it on Windows. So if I want to run this, I can say Rooster, and this is going to run this program, and it is basically going to say hello from C++20, and it's going to say the sum is 10. Let's look at the source code again, because you really need to see this to understand how we are getting this output here. We have a simple template function. It's going to add up two things, and we specify that we want to only add up integers. If we pass something that is not an integer, we're going to get a compiler error because of this concept here. So we go in main and we print out our hello message, and we say the sum is whatever it is we get by adding up 7 and 3 here. Okay, so this is our program, and we were able to build it using the G++ compiler. But we can also use another compiler. Let's clear this, and we're going to remove our Rooster binary here. Now we want to use the compiler from Microsoft, and that compiler happens to be called CL, as you see here. But to get access to that compiler without any issues, we're going to use the command prompt that comes with Microsoft Visual Studio. I am going to go to my start menu here, and I am going to say developer, and I am going to get either a PowerShell or a command prompt I can use on Windows here. I am going to use PowerShell because this is what I like to use. And I am going to change to the location of my project here. I am going to copy the location to that. I am going to change to the E drive on my computer here. And I am going to cd into that location so that I am in this location where I have my main CPP file here. Let's check and see that we have access to the compiler. We're going to type cl.exe, and we're going to get a message here, Microsoft, this is the compiler, this is the version, and we can use it to do things in our C++ programs. So we're going to run this command here and compile this using our compiler here. We're going to say cl.exe. We're going to specify a few parameters. I don't really want to get into these parameters. You can check this out if you go to the documentation for this compiler here. If you have any problem, please do ask. I will do the best I can to help you out. I just want you to see the process you go through to build things yourself on the command line. So we're going to specify the ZI parameter here. We're going to specify that we want to use the latest C++ standard we can get our hands on. So we're going to say C++ latest here. And we're going to specify EHSC, and we're going to say FE here, colon. We're going to specify the output file we're going to get from our compilation here. We're going to say rooster.exe, and we're going to say the input file. We're going to specify main CPP here. And let's compile this program. You're going to see that we get a few output files here, but the most important one is the rooster.exe file that we can run and see the output. You see that we get the same thing that we got from running our program from a binary that we got from GCC, but we don't have this anymore here, but no problem. So now you know that you can compile your program using different compilers on Windows, at least here. But it is possible to do the same thing even on Linux. I happen to have a window open on my Linux computer here. This is not a Linux computer, I should be honest with you. This is a Linux image I have access to through a technology called Windows Subsystem for Linux. This is really cool. And you can learn more on this by going to the Wikipedia link here. You can learn all you want about it. You can even check this on YouTube. There are a lot of people making videos on this. So I'm not going to talk anymore about this. What we're going to do is to hop over on our Linux system here and do dir. We can't do this, can we? We can't. But if we do dir in lowercase here, we're going to see the files that I have in my folder here, and I happen to be having a build of my program on Linux. Let's prove that we are on Linux here. And hopefully you're going to see that this is my Linux box. It is running Ubuntu 20.04, and we can use it to do our things here. So I have a rooster file that I want to remove. So I am going to remove this. And if I do a dir again, we're going to see that we have our main CPP file. We can print it out and show you that it is the same thing we had on Windows in a minute. But we want to build this program, and we're going to use the same command we used on Windows because it is basically GCC. So let's do that. We're going to build this. We're going to say G++ version, and we're going to see that this is the version I have here. And if you want to install a recent version of GCC on your system, there is a guy who does that. And I am going to share the link here. And if you go down, you're going to see that they have a title on installing multiple versions of GCC. You can just run sudo apt install and choose the version of GCC that you want. So I have installed GCC 10 and G++ 10 because that's what I want. And this gave me access to the version that you see here. Another thing that I should point out is that this is not going to give you a debugger. So for example, if I run GDB version here, this is going to say my version of GDB. You're not going to get GDB by running this command, but it is easy to get an install of GDB by just doing sudo apt get install GDB. If you do this, you're going to get it installed. And I have it installed already, so this is not going to install it. But if you don't have it, this is going to install that on your system, and you can use it to debug your C++ programs. So this covers how we get an install of GCC on our Linux system. But what we really want is to build this program and generate a binary for it. So we're going to do that. We're going to bring up our terminal again, and we're going to run G++, and we're going to say G to build and link our program. We're going to specify the C++ version. We want C++ 20, and we're going to specify the input file, and we're going to say that the output should be a file named rooster. Okay, if we do this, this is going to say std C++20. I have a typo here. Let's go back and fix this. It is not a colon, it is an equal sign you should use here. If we do this, this is going to build our program. If we do ls on Linux, we're going to see that we have an executable file. If we do ls-alh, we're going to see all the information here, and you see that this is an executable file. So we can run it. We can say rooster, and this is going to run this program, and we're going to see the output here. Hopefully you can see that there are different commands on different compilers and different operating systems to build your C++ program. And this turned out to be a mess if you really want to build your C++ program on different platforms. And CMake is an effort to try and fix this problem. You are going to describe how your C++ project is put together using a CMake list.txt file. And you're going to pass this file into CMake, and CMake is going to generate a project that you can easily build on your machine. For example, on Windows, we might get a Visual Studio project. We might get a MinGW project that we can really build easily. On Linux, we might get a Makefiles project that we can build very easily. But we're not going to do that in this video because in here, I just want you to get a feeling of what CMake is and the problem that CMake was invented to try and solve. And the problem is that we don't want to build our programs by directly calling our compilers like this, because this is messy. On Windows, you're going to have Visual Studio and G++ like we have here. On Linux, you're going to have G++. But on a Mac, for example, you're going to have another set of tools. I think they use Clang as their default compiler, but you don't want to be doing this. You want to abstract all of these things into something that you're going to use to build your C++ project easily, regardless of where it's going to run. And CMake is an effort to try and really solve this problem. So in this video, the goal was really to give you the concepts on CMake and what it is. It is a build system generator. It is going to generate projects that you can then build easily on whatever platform where you are trying to build your C++ projects. It is going to solve the problem of building your C++ projects directly on the terminal by calling the compiler yourself. It is possible to abstract these things using scripts. For example, you can use Bash, you can use Python, you can use batch scripting, but we're not going to go through that because CMake really makes this easy by providing a unified language, if I can say that we can describe our C++ project in, and it's going to be really easy to build our projects. Okay, so now that you have an idea on what CMake is, let's look at how you can install it, because I don't think I showed you that. I am going to minimize this a little bit, and we're going to hop over to the website for CMake. I think they have links to download this directly. If you hit download, you're going to have release candidates here, but we don't really want that. We want a stable release of CMake. So if you hit this title here, you're going to have a location where you can download CMake. For example, if you are on Windows, you're going to download a binary of this here. If you are on a Mac, you can download this and install it on your Mac system. If you are on Linux, you can download and build it yourself. I have my CMake installed in my C drive. If I go in my C, you're going to have, I have a folder on CMake, and I have my binary for CMake in here. This is what we're going to be using in this series on Windows. I made sure I have this path added to my environment variables. So if I go on my start menu here and say environment, I am going to have an option pop up to edit my system environment variables. If I click on this, I am going to choose environment variables, and I can click on my path here. Let's double click, and you're going to see that I have a path to my CMake installation here. Let's make sure we have this in. Let's cancel this and look at my path for the user. This is here. Okay, so it is my environment variables for my user account. I didn't install this on my system or system-wide. I installed this for my user account, and that's why we are able to pick this up here, this version of CMake. So if you are on Windows, this is what you need to do to get your CMake, and you can use it however you want. If you are on Linux, let's go on our Linux system here. If you don't have CMake installed, let's try and run it here. CMake, if I can type this, we're going to say version. We're going to see the version we have on our Linux system here. You see we have an older version, but this is okay. We don't want to do all kinds of crazy things with CMake at this point. This is going to serve us well. And if you don't have it installed, all you have to do is to do apt get install CMake. This is going to install it on your system. I have it already installed, but if you don't have it, this is going to install it on your system. So you need to have CMake installed on your system to be able to do what we want to do in this series of videos. Okay, now we know how to install CMake on our system. What we will be doing in this series of tutorials is to build cross-platform C++ applications using C++ and CMake. We will start by doing things on desktop using Windows and Linux, but eventually my hope is that we will also be able to use CMake to target Android, iOS, and even embedded devices, basically doing something like Qt is doing, but we're going to dive deep and really see how this works. I am going to be using Visual Studio Code as my editor here. You can use whatever editor you want, and we will basically be doing things on Windows and Linux. Okay, so this is really all I wanted to cover in this initial tutorial on our CMake tutorials. I hope you found it interesting. If you have any ideas on the tools or what we should cover in this, please do share in the comments below. I am going to stop here in this video. In the next one, we're going to start and really dive into CMake and set up a project that we can build both on Windows and Linux. And you are going to see how cool this is. Okay, so this is all for today, and I will see you next time.